Good evening, all of you. Today, we are going to discuss about trigonometric identities. What do you mean by an identity? Identity means uh, it is true for all the set of values which we are considering. Okay, now, mainly to understand these identities, first let us talk about what we have learned earlier. So already we discussed that in a right angle triangle, what do we call the side opposite to 90 degrees? Do you remember that? What do we call the side opposite to 90 degrees? Opposite to 90 degrees, this side is called hypotenuse. We know this. And further, if we consider this angle like some theta, then in terms of this angle, this side will become opposite side and this will become adjacent side. And we know the relation between these three. What is the relation between them? We know that hypotenuse square is equal to opposite side square plus adjacent side square. This is what we already know. Yeah, good evening all of you. Now we are talking about trigonometric identities. In this, once again, we are recollecting the Pythagoras theorem result. In a right angle triangle, always we can say that square of hypotenuse is simply equal to the sum of squares of other two sides. Okay, mainly we have three trigonometric identities. What are those three trigonometric identities? First one is sine square theta plus cos square theta equal to 1. And second identity is 1 plus tan square theta equal to secant square theta. Third one is 1 plus cot square theta is cosec square theta. These are the identities, correct? Of course, all of us are very much familiar with these three identities. Now, first let us try to understand how do we prove these things. For this, of course, there are different methods for proving or understanding these things. Now I am selecting the easiest way in these three. What is that? Already we know this result. Now I am going to make use of this result for proving these three. So ABC is the triangle. In this, AB is opposite side, BC is adjacent side, and AC is hypotenuse. So what is the relation? I can say that AB square plus BC square is equal to AC square. Just simply I am using this. Hypotenuse is AC. So hypotenuse square is equal to opposite square plus adjacent side square. This is actually the Pythagoras theorem result. Now I am taking this for proving these three identities. These three are the identities, but we are going to prove these three very easily by using this. How do we prove? Let us see. I am going to the next page. Here we already know that AB square plus BC square is equal to AC square. Now divide throughout by AC square. What do we get? AB square by AC square plus BC square by AC square is equal to AC square by AC. Now once again just recollect what is the triangle. I think you do remember this is full one because we used it several times. This is ABC. We consider this angle like theta, your hypotenuse, opposite, adjacent. Good. Now here simply we can write this like AB by AC whole square plus BC by AC whole square equal to AC by AC. Now you observe what is AB by AC? AB by AC. What is AB here? AB is opposite. AC is hypotenuse. What is opposite by hypotenuse? We know that it is sine theta. Likewise, what is BC by AC? BC is adjacent and AC is hypotenuse. So we can observe it is cos theta. Now simply we can replace AB by AC with sine theta and BC by AC with cos theta. Then I get it like sine theta whole square plus 2. Of course, we know that AC divides AC one time. That is 1 square. So from this now I can say sine theta whole square is sine square theta plus cos theta whole square is cos square theta equal to 1. Actually, this is your first trigonometric identity. This is what we discussed. I hope you understood this. Okay. Is it clear to all of you? A simple procedure. Just simply we are considering Pythagoras theorem and we know that AC square is equal to AB square plus BC square. Correct? So simply we are making use of that result and dividing by throughout by AC square. I am getting like AB by AC whole square. But as per the ratios, AB by AC means it is opposite by hypotenuse and we know that opposite by hypotenuse is sine theta. So here I can write sine theta. Likewise, BC by AC is adjacent by hypotenuse and we know that it is cos theta. So that's how we get the first trigonometric identity. Okay. Yes, fantastic. Now let us try to understand the second trigonometric identity. You see, the interesting thing in all these things is I am taking the same result again and again. AB square plus BC square is equal to AC square. Now here, what is the triangle we took? We considered a right angle triangle. This A, this is. Of course, we know that this is news. If this angle is theta, opposite, this is adjacent. And every time we know that hypotenuse square is equal to opposite side square plus adjacent. So earlier we divided with AC. Actually here we have three things. So AB, BC, AC. In first result, we divided throughout with AC square and that's how we obtained the first identity. Now suppose if I divide throughout with BC square, then what do we get? Let us see. Divide throughout by BC square. Now what am I going to get here? You observe AB square by BC square plus BC square by BC square equal to AC square by, right? Simply I divided throughout with BC square now. Now simply it becomes AB by BC square plus BC by BC whole square plus AC by BC. Okay, here it is, right? Now again just think of it. Here first one is AB by BC. What is AB by BC? As per this diagram, AB is opposite side and BC is adjacent side. Yeah, what is opposite side by adjacent side? All of you type it in the chat box. What is the ratio opposite by adjacent? Come on. What will it become? Opposite by adjacent. All of you type it quickly in the chat box. Opposite by adjacent. Can you tell me? Yes, I'm waiting for your answer. Akhil, Ramos, Ramzi, Monica. What is opposite by adjacent? What is the trigonometric ratio? Yes, fantastic. It is tan. Because we are talking about in terms of angle theta, I can say tan theta. Likewise, the other one is, of course, here we know that BC divides BC one time. And the next one is AC by BC. What is AC? What is BC? AC is hypotenuse and BC is adjacent. We know that adjacent by hypotenuse is cos theta and this is the reciprocal of that hypotenuse by adjacent. Yeah, come on, you try. What is hypotenuse by adjacent? Hypotenuse by adjacent. What is the trigonometric ratio? You try. I hope you can hear my question. What is hypotenuse by adjacent? Type it in the chat box. I am asking about hypotenuse by adjacent. What is the trigonometric ratio? Just try. It is reciprocal of cos. It is reciprocal of cos. It is not cos. Cos is adjacent by hypotenuse. Cos is adjacent by hypotenuse. But it is hypotenuse by adjacent. What is the reciprocal of cos? Reciprocal of cos is secant. Okay, I think by this time you understood what we are going to get here. So AB by BC now can be replaced by tan theta and AC by BC can be replaced by secant theta. So if we write them in this, I get it like tan theta whole square plus this is 1 square is equal to secant theta whole square. So the same thing we write like 1, this is tan square theta plus 1 is equal to secant square theta. Okay, this is our second identity. And I think by this time you understood how do we get these identities and how do we get the third identity. Already we divided with AC square, then we divided with BC square. So for the third one, what we are supposed to do? Can you go for a guess? For getting the third identity, we have to divide with AB square. Okay, afterwards you can try that. I'm just leaving it like for a practice thing. So same equation you take, AB square plus BC square is equal to AC square. Now divide throughout by AB square, because with BC we divided, BC square we divided, AC square we have seen in the first one. Now what is left? AB square. Now what happens? Now let us observe that. We know that AB square plus BC square is equal to AC square. Okay, I hope some of you are unable to see this figure. So right, I will draw it a little bit below this so that you can. Yeah, fantastic. This is theta. Of course, I know that this is hypotenuse, this is opposite, this, right? Name it like some ABC. Now we know that AB square plus BC square is equal to AC square. Now what to do? Divide throughout by AB square. Now what happens? AB square by AB square plus BC square by AB square. So simply I am dividing each term with this AC square by AB square. Now here we can write it like AB by AB whole square plus BC by AB square plus is equal to, right? Just observe, this is equal to is AC by AB. Now the immediate observation is AB divides AB one time because both are same. So it is 1 square. Then what about the remaining? Again in this you want BC by AB. What is BC here? As per this, BC is adjacent by AB is opposite. Yeah, again you type it in the chart box. What is BC by AB? Adjacent by opposite, what will it become? Come on, you try. What is that ratio that gives adjacent by opposite? Come on. All of you try this. Yes, Kishore, even you can try. Ramji, Monica, all of you can try. Akhil. What is adjacent by opposite? What is the trigonometric ratio that is equal to adjacent by opposite? Actually, opposite by adjacent is tan. Already you answered earlier. This is the reciprocal of tan. Reciprocal of tan is what? Cot. Good. Monica, you are correct. It is cot. Okay. Here it is cot. Of course, this is cot in terms of this angle. So we say cot theta. And one more is AC by AB. What is AC here? Again, you can see AC is hypotenuse. And what is AB? Opposite. Now again, you try. What is hypotenuse by opposite? We are familiar with opposite by hypotenuse. We know this is the reciprocal of that. Okay. What is hypotenuse by opposite? You try now. Come on, just I am waiting for your answer. What is hypotenuse by opposite? What is the trigonometric ratio? It is reciprocal of sine. What is the reciprocal of sine? Yes, you are correct. It is cosecant. Okay. So it is cosecant theta. So what can you write here? 1 square plus BC by AB is cot theta whole square is equal to cosecant theta whole square. Now we can see that this is 1 plus cot square theta equal to cosecant square theta. This is your third identity. I hope all of you understood this. These are the three identities which we have. The first identity is sin square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to secant square theta. And third one is 1 plus cot square theta is equal to cosecant square. Now here actually I have one interesting point that I would like to discuss with you. That is, in circles we talk about tangent, and of course even we talk about secant. What about that tangent and secant? Is it same as the tangent and secant which we are talking about? Are they the same or different? How do we know? For understanding that, let us observe this. Here, right, you just see here, and on the screen you can see a circle with center O, and P is any external point. See a circle with center O and P is any external point. Now just observe, from P, the external point, like it is joined to the center of circle O. External point P is joined to the center of circle O. Now what happens here? Just it is easy to observe, from that external point even a tangent is drawn. From that external point a tangent is drawn. Okay. From that external point a tangent is. Now what happens here? Simply what we can do here is, next you observe, here the circle which we considered is a unit circle. What do you mean by unit circle? Unit circle means radius is 1. If radius is 1, it is called unit circle. Okay. So we considered a unit circle. It has center O and radius 1 unit. And now you can see that from that tangent drawn from the end point of radius is always perpendicular to it. Now you can see here, this is 90 degrees angle. And that we know that a tangent drawn from the end point of radius is always perpendicular to it. So from this external point a tangent is drawn. So this is radius. So it is 90 degrees. Of course, because it is unit circle, radius is 1 unit and the angle is 90. Now this is a right angle triangle. Now what can we say about PA? You observe, PA is the tangent drawn from external point. So this PA will become tan theta. This PA is tan theta. Of course, OP is distance from external point to the center of the circle and it is secant theta. Okay. So it is a unit circle of radius 1 unit. Unit circle means radius is 1 unit obviously. PA is the tangent drawn from external point. Actually we can call it like tangent segment from external point to a circle. And we know that further tangent is always perpendicular to the radius at the point of contact. That's so we can observe that it is 90 degrees. And from the external point to the center of the circle, whatever the distance is there, that is equal to secant theta. Of course, we can prove all these things geometrically. Now I'm not going to the proofs, just I want to give you how you can remember these trigonometric identities very easily and quickly. This is the tangent which you studied and this is the secant. Now here you can see this is a right angle triangle. So what is the hypotenuse in this? Can you say now? What is the hypotenuse? Because this is 90 degrees, opposite is hypotenuse, means side OP is hypotenuse. So we know that hypotenuse square is equal to sum of squares of other two sides. That's so I get the identity like 1 plus tan. What is that identity? 1 plus tan square theta is equal to secant square theta, because this secant theta is opposite to 90 degrees, and we know that square of hypotenuse is equal to sum of squares of other two sides. Now further what we are going to do is, from this point A, you drop a perpendicular to OP. Okay, AF is drawn perpendicular to OP. Now you can see this is again another right angle triangle. AFO is another right angle triangle. In this, if you observe, this is theta and this is the opposite side. So here you can observe that AF, again you observe, because we are talking about triangle AFO. This is the triangle we are talking about. So what happens in terms of this? This is hypotenuse. So 1 square is equal to sin theta whole square plus cos theta whole square. That's how you get the second identity. That is sin square theta plus cos square theta is equal to 1. Okay. So this is just to remember the things very easily and quickly. And the third one is, through this O, draw a line parallel to AF. Okay. Now what happens here? Again you can see that at A the angle will be 90 degrees. So angle CAO will be 90 degrees. Further angle A will be theta. Right? The reason is this angle is theta, means this will become 90 minus theta, and that's so this will become theta. Of course, whatever we are showing here, you have geometrical proofs for all these things, but I am not going for proofs now. Just directly I am showing you the results here. You can prove all these things easily. Now what happens here? OC is cosecant theta and AC is cot theta. Again you observe, this is a right angle triangle. In this, as per this is 90, opposite is hypotenuse, so hypotenuse is cosecant theta. So that's how you can observe that 1 plus cot square theta is cosec square theta. This is the way in which easily you can remember these three trigonometric identities. Just we are taking the help of these trigonometric identities. So by using the idea of similar triangles, you can prove these things very easily and quickly. But we are not going for all those proofs. Just we are remembering the results, right? For a quick understanding of the results, it is very much helpful. Now let us go back to our identities. So till now we discussed mainly the three identities. I think all of you remember. Now we are going to solve some problems using these identities. Okay, we are going to solve the problems. What are the three identities? That first one is sin square theta plus cos square theta is equal to 1. Next one is 1 plus tan square theta is equal to tan square theta. Third one is 1 plus cot square theta equal to cosecant. These are the three identities. Just we make use of these identities for solving the problems. Now the first problem is given like this. Show that tan square theta minus 1 by cos square theta is equal to, okay, already earlier also we discussed LHS, right? First let us start with LHS. 1 by cos square theta, we know that 1 by cos square theta is 1 by cos theta whole square. So 1 by cos means reciprocal of cos. What is the reciprocal of cos? We know that it is secant. So it becomes secant theta whole square. That's why I can say it is secant square theta. Okay. So first step, simply obtain tan square theta is as it is 1 by cos square theta. 1 by means it is the reciprocal of cos, so it became secant square theta. Now what is the identity? You have to use tan secant. You can observe that these two are pretty. Okay, what do I know here? Now simply observe, we know that 1 plus tan square theta is equal to secant square theta. Now you bring this secant square theta also to the left hand side. 1 plus tan square theta plus secant square theta, if you bring it to the left hand side, it becomes minus secant square theta is equal to 0. Now I have only tan square theta minus secant square theta. Means I want only this much. So send it to the other side. So tan square theta minus secant square theta is equal to this plus 1. If you take it to the other side, it becomes minus 1. So that's why I can say it is minus 1. It is solved. A very easy problem. First you have to understand what is the method we are adapting, we have to use. Then you have to go for some simple manipulations to reach the required result. I hope all of you understood this, right? Now earlier also, but just I want to repeat it. Express cos theta in terms of tan theta. Okay, now you see, I want to express cos theta in terms of tan theta. Now, if you observe these three identities, what are the three identities we have? Sin square theta plus cos square theta is 1. 1 plus tan square theta is tan square. Third one is 1 plus cot square theta is equal. These are our three trigonometric identities. Now, which one we have to use? So simply you observe. First, I have to express it in terms of tan theta. Tan is here, but tan is not connected with cos. But what is it connected with? Secant. So how am I going to do this? You observe. Simply first we start with cos theta, and I have to express it in terms of secant. We know that secant is the reciprocal of cos. So I can write cos theta as 1 by secant theta. Now you observe, what is secant theta? Here as per this identity, secant square theta is 1 plus tan square theta, but I don't have square, right? You observe here. I know that secant square theta is equal to 1 plus tan square theta. But I have only secant theta. So to obtain that, take square root on both sides. Now this square and square root are cancelled. So that's why I get secant theta is equal to root of 1 plus tan square. Now simply this result you substitute here. So I can get 1 by of 1 plus tan square. You see, now the problem is completed. This is cos theta and I have to write it in terms of tan theta. Means my final answer must contain only the terms of tan. Here it is achieved very easily and quickly. I hope all of you understood this, right? This is another way of solving this problem. Already in part 1 I discussed how to express these things in another method. You just go through these two methods, whichever is convenient to you, whichever you can understand it in a better manner, you can follow. There is no rule that you have to do it only in this method or only in that method. It is up to you. You can use any one of these things, right? Now let us go for one more problem. Now next problem is given like this. So that 1 plus cot square theta to 1 plus cos theta to 1 minus cos theta equal to 1. Right. At a glance, if we observe, this is seem to be like a very lengthy problem and this is very difficult like. But it is very easy to solve. First, you check this 1 plus cot square theta. What is it equal to? So easily we can recollect that this is the identity 3. 1 plus cot square theta is cosecant square theta. So first one simply by using the third identity. Okay, if you want, I will write them here again. First one is sin square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to sec theta. Third one is 1 plus cot square theta is equal to. Now I think by this time you understood what is the identity we used. What is the identity we used? I straight away used this third one. I know that it is 1 plus cot square theta. So simply I wrote it like it is equal to this. So I can replace 1 plus cot square theta by cosecant square. Next, observe these two. 1 plus cos theta into 1 minus cos theta. If you consider this like A plus B into A B. Now we know that A plus B into A minus B in algebra identities we learnt it several times. A plus B into A minus B is A square minus B square. We know this. But what is A here? 1. So 1 square minus cos theta. Now, right, this is, I started with LHS and from LHS I obtained this. Now, okay, you leave it like cosecant square theta into, you observe this, it is 1 minus cos square theta. What is the identity we have to use now? I think easily you can observe this. What is the identity we have to use now? You observe. What is the identity we have to use? We know that sin square theta plus cos square theta is equal to 1. But I have 1 minus cos square theta. So what to do? Simply this cos square theta, you send it to the other side. So I can observe that sin square theta is equal to 1 minus cos. So now here I can see this is 1 minus cos square theta, which is simply equal to this. So I can replace this with sin square theta. Now further we know that sin and cosecant are reciprocals, right? So I can write the cosecant square theta like 1 by sin square theta into sin square theta. Right? What else? Sin square theta divides sin square theta 1 time, 1 into 1, 1. That's how you can say that it is proved. Okay. So, right, before going to solve few more problems, just let us try to analyze these things. First of all, you should know sin, cos, okay, I write sin theta, cos theta, tan theta. These are the ratios. And what are their reciprocals? Do you remember? For sin theta, the reciprocal is cosecant theta. And for cos theta, the reciprocal is secant theta. For tan theta, the reciprocal is cot theta. Means what does it mean? Sin theta into cosecant theta equal to 1. Means I can say sin theta is equal to 1 by cosecant theta, or I can say cosecant theta is equal to 1 by sin theta. This is the first one. Likewise, second one is cos theta into secant theta is equal to 1. Means I can say cos theta is equal to 1 by secant theta, or secant theta is equal to 1. And third one is tan and cot. We know that tan theta into cot theta is equal to 1. So from this I can say tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan. These are the things even we discussed earlier because they are reciprocals. What do you mean by reciprocal? Their product is 1. So one is the reciprocal of the other. Means cos theta is the reciprocal of secant and secant is the reciprocal of cos. Likewise, sine and cosecant. What is the logic in this means? You observe in this right angle triangle, if you observe, if this is theta, this is opposite, this is adjacent, and this is hypotenuse. How we are saying these two are reciprocal means, here you can observe that sine theta is equal to opposite by hypotenuse, whereas cosecant theta is equal to hypotenuse by opposite. Now if you multiply these two, what happens? Sine theta into cosecant theta is equal to opposite by hypotenuse into hypotenuse by opposite. Opposite cancel, hypotenuse cancel. That's how you get 1. The same kind of explanation even you can give for this and this. Okay, this is the way in which we can. That's why they are called reciprocal to each other. Okay, next one is, like we are talking about the first identity, sine square theta plus cos square theta. From this we can write some important points. Suppose if I want sine theta, how can I write? You observe, sine square theta is equal to, now because I want only this, I have to send this cos square theta to the other side. Because it is plus, if you take it to the other side, it is minus. So that's why I can say 1 minus cos square theta. Suppose if I want only sine theta, it is sine square theta. If I want only sine theta, what to do? Because it is a square, its reverse operation is square root. So square root of sine square theta is equal to square root of 1 minus cos square. That's so I can observe that sine theta, because this square and square root cancel, so sine theta is equal to root of 1 minus cos square. Here you may get a doubt, sir, here you are cancelling this square and square, why you are not doing so? Here this is not the only term, even I have here. If it is like root of a whole square, that square and square root can be cancelled. But here I don't have such a facility. I cannot express it like a single term whole square. So it will be like this only. I hope you understood this. Right? In the same manner, if I consider cos square theta, now the same thing I am doing with cos square theta. Suppose if I want cos square theta, what can I do? At that time I want this. So this term is to be taken to the other side. So that's how I can say it is 1 minus sine square theta. And again the same thing, if I take square root, I get cos theta is equal to root of 1 minus sine square. Okay, means actually this is the first identity, and by using this identity we can get some other products. Okay, so these are like the additional results which we can obtain from the identity which we have proved. So simply these are, but don't feel tension, don't think that you have to by heart all these things. Simply if you understand how we obtained this, that's why I explained you these things, so that whenever it is needed you can make use of these results for proving. So whenever you have sine square theta, you can replace it with 1 minus cos square theta. Whenever you have cos square theta, you can use 1 minus sine square theta, and so on. This is with the first identity. And what is the second one? Yes, tan square theta is equal to secant square theta. Now the interesting fact, now if I send this tan square theta to the other side, then I get like secant square theta minus tan square theta equal to 1. And now you observe it is resembling like a square minus b square. What is the formula for a square minus b square? We know that it is a plus b into a minus b. Here what is a? Secant theta is a and tan theta is b. So here I can write it like secant theta plus tan theta into secant theta minus tan theta equal to 1. So here again you can see this is into, means this is the product. So I can write them like secant theta plus tan theta is equal to 1, because it is into, it becomes by secant theta minus tan theta. Or the other one is, if I take secant theta minus tan theta, now I can write it like 1 by secant theta plus tan theta. This is the way in which from that again we can get few results. Okay, the same thing is quite applicable even for the third result. What is the third result? We know that it is 1 plus cot square theta is equal to cosecant square theta. Of course, we know this result. In the same manner, if you do, you get it like cosecant square theta minus this cot square theta. If you take it to the other side, it becomes minus cot square theta is equal to 1. Now again it is like a square minus b square, which is simply the product of a plus b and a minus. So that's how I can write it like cosecant theta plus cot theta is one term into cosecant theta minus cot theta equal to 1. Because here it is into, again I can write them like cosecant theta plus cot theta is simply equal to 1 by cosecant theta minus cot theta. Is one result. Or the other one is cosecant theta minus cot theta is 1 by cosecant theta plus cot theta. Okay, this is the way in which we can obtain few results which are helpful. Okay, I hope all of you understood this, to understand how we can make use of these things. Okay, now let us go for a few examples where we can make use of this. I will show you one problem so that you can understand how can you make use of it. Let us go for one problem on this. Now this is actually like a standard problem. Most of the times these kind of problems will be given. If suppose you know that secant theta plus tan theta is equal to p, then prove that sin theta is equal to p square minus 1 by p square plus 1. Again, the interesting fact is you can solve this problem in different ways. Okay, there are different ways for achieving this. Now I will show you one by one what are the different ways you can use for solving this problem. First of all, you observe, if we use this identity, first thing is, what is the identity? It is theta minus tan square theta is equal to 1. So that is actually, we know that 1 is equal to secant square theta. So plus tan square theta, send it to the other side. That's how you get this. Now it is like a square minus b square. So secant theta plus tan theta into secant theta minus tan theta is equal to 1. Okay, this is what we are going to make use of. Now simply just you apply it here. Then what happens? You observe secant theta plus tan theta into secant theta minus tan theta equal to 1. Actually, it is obtained from the identity secant square theta minus tan square. But as per given data, secant theta plus tan theta is p. So p into secant theta minus tan theta equal to 1. So I can get secant theta minus tan theta 1 by p. Now you observe, this is one equation, secant theta plus t, secant theta minus tan theta is 1 by p. Now you already learnt linear equations, like now you can make use of it for solving these two equations like p by 1. So simply we multiply both numerator and denominator with p so as to get it. So now you can see that 2 secant theta is equal to p square by p plus 1 by p. So you can see it is p square plus 1 by p. So from this you can get secant theta is equal to p square plus 1 by this 2. If you take it as it divides to 2p is equal. Okay, now the same equations I am taking. Secant theta plus tan theta is equal to p. Secant theta minus tan theta is equal to 1 by p. Now subtract. On subtracting, earlier we added, now we subtract. So minus plus minus. So now these two are cancelled. So you get 2 tan theta is equal to p minus 1. Of course, this is like 1. So into p by p we will do. Then 2 tan theta is equal to p square minus 1 by p. So tan theta is equal to p square minus 1 by, so this is 4. Now actually what we have to prove, you observe what we are supposed to prove here. What we have to prove, we want p square minus 1 by p square plus 1. So for getting this, simply I will take this. So I am going to write it like 4 divided by 3 means p square minus 1 by 2p by p square plus 1 by 2p equal to, what is p square minus 1 by 2p? Do you remember? P square minus 1 by 2p is tan theta and this is secant theta. So I can say it is tan theta by secant theta. Very good. So now actually denominator you can cancel here, or you can write it like p square minus 1 by 2p into this denominator, the terms will be reversed. So you get it like 2p by p square plus 1 is equal to, here this one you take tan theta means sin theta by cos theta, secant theta means 1 by cos theta. Now this 2p cancel. So p square minus 1 by p square plus 1 equal to sin theta by cos theta to cos theta 1. So we know that cos theta divides cos theta one time. So that's how you get sin theta for required proof. You see, this is one way of solving this problem. Okay. So of course there are different methods for solving this problem as we discussed earlier. Always remember what is the method you are adopting. First you have to plan. That's why whenever you were given the question paper, first read the question thoroughly, understand that, and then you start solving the problems. Okay. Then you can understand it in a more easy and quick manner. Now let us see one more problem. Actually, even you will see sometimes the questions like root of 1 minus sin theta by 1 plus sin theta. You are asked to show that it is equal to something like secant theta minus tan theta, something like that is equal to secant theta minus tan theta. How do we solve this? Is it not interesting? So simply first you start with LHS. Show that, prove that means right hand side is the expected answer. So first simply you start with left hand side 1 minus sin theta by 1 plus sin theta. Now it is like a fraction inside the square root. So you multiply both numerator and denominator with 1 minus sin theta. The same term I am multiplying. So because of this, you don't find any change in this, because what happens again, these two are cancelled one time, and 1 into this is this. So there is no change in the expression. Now you observe what happens. Square root of 1 minus sine theta into 1 minus sine theta means 1 minus sine theta whole numerator. Because the same term is 2 times. We know that x into x is equal to x square, y into y is equal to y square. Like that, 1 minus sine theta and 1 minus sine theta is this. And what about the lower one? You can see denominator is like a plus b into a minus b. Already we are very much familiar with this identity. It is a square minus b square. So a is 1. 1 square is 1 minus sine square theta. So here it is 1 minus sine theta whole square by, and 1 minus sine square theta. What is the identity we have to use? Just to recollect, we know that sine square theta plus cos square theta is equal to 1. Because I want 1 minus sine square theta, this sine square theta, you send it to the other side. You can see cos square theta is equal to 1 minus sine square. I think by this time you understood what I have to replace this. I can write, because these two are equal, now I can write here cos square theta. So what else? Now I can write it like root of 1 minus sine theta whole square by root of cos square theta. Now you observe, this is not the square of only one term, it is for the whole term. So I can cancel this square and square root, and here also square and square root. So I get 1 minus sine theta by cos theta. What do you mean by that? 1 minus sine theta by cos theta means, here you can write it like 1 by cos theta minus sine theta by cos theta. And of course, we know that 1 by cos theta means theta minus sine theta by cos theta is tan theta. This is your right hand side, observe. That's so you can prove this result very easily and quick. Okay. So whenever we are solving these problems, we have to keep it in our mind that what is the identity we have to use. In general, you have to check for uh, those ratios, relation, means sine square theta plus cos square theta is equal to 1. It gives the second. So which you will observe in the second and third. So you can convert them from one form to the other comfortably as per the requirement, and we can solve the problems. I hope all of you understood this. Now just I will show you one more problem. Right? Chalo, let us go for one more question. Right. Suppose if you want, like, why every time we have to consider it like in a specific manner? Because the reason is the problems while solving, as we discussed earlier, we can solve it in different manner. And uh, right hand side always will give you the expected answer. Means sometimes we give it like the product, and sometimes we can obtain it the other way, like. And to understand this, let us consider one problem, and we can take it like this. Okay, what is the problem we can take? Hello. What is the most interesting question? Like the simple questions we can choose. Right? Always the way in which we solve is more and more important. Now, let us try this problem. Cos theta by 1 minus sin theta plus 1 minus sin theta by left hand side, you take LCM is 1 minus sine theta times cos theta. Now we know that this 1 minus sine theta divides it cos theta times. So cos theta into cos theta, cos square theta, plus again 1 minus sine theta into 1 minus sine theta. It is 1 minus sine theta whole square. So I started with LHS and I obtained. Okay. Now it is cos square theta plus 1 minus sine theta whole square is 1 plus sine square theta. It is like a minus b whole square. A minus b whole square is a square plus b square minus 2ab. So 1 plus sine square theta minus 2 sine theta by denominator is 1 minus sine theta into cos theta. Okay, there is no. Now again you observe what is the identity you can use. We know that sine square theta plus cos square theta, the sum of these two is 1. So 1 plus 1, 2. 2 minus 2 sine theta by 1 minus sine theta into cos theta. What we obtain. Now what we can do here, just observe. In this, now you can take 2 common in the numerator. So 2 times of 1 minus sine theta by minus sine theta to cos theta. Resting. Minus sine theta divides 1 time. So here I obtained 2 into 1 by cos theta. But what is the reciprocal of cos? We know that it is secant. So I can say it is 2 secant theta, which is your right hand side. You see, simply here I used sine square theta plus cos square theta is equal to 1. This is one identity I used, and here I used a minus b whole square formula. Like this, whatever the formula which we learned, we are using and we are solving these problems. So basically you have to understand these identities in a better manner so that you can solve these problems very easily and quickly. I hope all of you understood these problems and how to solve. Now I am giving you some problems for homework. You can try. Just I'm going to give you some problems. You can try them one by one. So the first problem is, show that secant theta minus tan theta whole square equal to 1 minus pi. Next one is, like, you can try, prove that 1 by 1 plus sine theta plus 1 by 1 minus sine theta is equal to 2 secant square theta. And one more is, show that root of 1 plus cos theta 1 minus cos theta is equal to cosecant theta plus cot theta. Okay, and I think you can try one. Prove that 1 by sine square theta minus cot square theta. Okay, you try these problems.